Large language models can generate complex code or draft legal briefs in seconds, yet a single adversarial prompt can bypass their internal logic. This fragility creates a paradox. The more capable the model, the more damage it can do when it deviates from its intended path. In an enterprise environment, the objective extends beyond simple output generation. Professional prompt engineering requires a dual focus on both semantic clarity and operational security. These models act as accelerators for the operator's intent. Whether the goal is to streamline medical research or automate a phishing campaign, the AI scales that effort without a built-in moral filter. Deploying a raw, unprotected language model introduces unnecessary risk. High-stakes operations require us to build a multi-layered defensive perimeter around the core system. Relying on the AI to be its own gatekeeper is a known operational hazard. True system mastery requires the construction of a comprehensive trust architecture. First, the security perimeter intercepts malicious injections. Next, the data and privacy shield prevents sensitive PII from leaving organizational control. Third, the epistemic filter identifies hallucinations through fact-checking. Finally, the ethical framework establishes human oversight and accountability for all automated outputs. These layers provide the stability required for enterprise use. Without them, the risks of data leakage and systemic error make the technology too volatile for professional environments. Prompt injection occurs when malicious commands are hidden inside a standard user input. This technique allows an attacker to overwrite the AI's core instructions and hijack the session for unauthorized tasks. Direct injection uses explicit commands like ignore previous rules to expose internal configurations. Indirect injection occurs when an AI analyzes a compromised web page containing hidden malicious instructions. Because the AI interprets this text legitimately, the system is compromised without direct user interaction. Securing these boundaries requires a technical separation between system prompts and user inputs. Engineers must enforce least privilege permissions, ensuring the AI only has access to the specific data needed for its task. On an individual level, security depends on verification. Never copy-paste unverified prompts from public repositories into enterprise systems without a full audit of the text. Since language models process commands and data through the same channel, rigid input validation remains the only reliable method for maintaining system integrity. Jailbreaking represents a deliberate attempt to dismantle the manufacturer's safety and ethical filters. Users often employ psychological framing to bypass these guards, using role-playing or fictional scenarios to trick the model into generating restricted or dangerous information. These attempts carry significant risk, including permanent account bans and legal liabilities. Furthermore, they actively undermine the safety protocols that protect the broader user base. When legitimate professional queries are blocked, provide clear context rather than trying to subvert the model. Explicitly stating a professional role, such as a doctor or legal researcher, helps the model navigate its safety constraints without compromising its logic. Bypassing safety guardrails introduces unpredictable variables into the system, which compromises the reliability of every single subsequent output. Conversation data sent to AI models is frequently stored on external servers and may be used for future model training. This creates a direct privacy risk. Sensitive government identifiers, such as Aadhaar numbers, must never be included in an AI prompt. The restriction extends to all financial data. Entering PAN numbers or credit card details into a third-party chat interface exposes that information to the model's host. Passports, citizenship records, and other international travel documents are similarly restricted under this zero-share protocol. Sharing this data can lead to regulatory violations. Transmitting protected information to foreign servers often breaches data localization laws, like the GDPR and India's DPDP Act. To maintain privacy while using AI for analysis, use anonymization. Replace real names and specific account numbers with generic identifiers, such as Customer A or Account X. Safety in a digital environment requires treating every prompt as if it were being posted to a public forum. The model operates as a sophisticated pattern matcher. It predicts the most likely sequence of words based on its training data, rather than retrieving facts from a static, verified database. This approach has inherent limits. The AI lacks physical common sense, has no emotional intelligence, and remains blind to any events occurring after its knowledge cutoff date. Technical weaknesses are common. Most models struggle with multi-step mathematical calculations and frequently miss cultural or regional nuances due to English-centric training sets. These limitations result in hallucinations, instances where the AI invents facts or references and presents them with high confidence. This risk also applies to synthetic media. As deepfakes and AI-generated texts improve, traditional visual indicators like unnatural blinking patterns or overly perfect grammar are becoming less reliable as methods of detection. To maintain accuracy, every AI output must be treated as a draft. Users must cross-verify all statistics, quotes, and dates using primary sources like official websites or academic papers. Neglecting the epistemic filter allows a single AI hallucination to scale into systemic misinformation. Operational ethics provide a framework for managing reliability and accountability. This translates abstract values into measurable business metrics, like output transparency and the reduction of bias. First, define the specific purpose for using AI on any given task. Second, verify all information before integrating it into a final product. Third, maintain transparency by disclosing AI assistance in your professional work. Fourth, respect privacy by sharing only the minimum data required for the task. Fifth, ensure inclusive use by actively auditing outputs for bias against marginalized groups. Sixth, maintain human oversight. The final decision maker must always be a human operator. Seventh, commit to continuous learning as AI policies evolve. Eighth, provide feedback to developers when you identify model errors or bias. Ninth, protect your own skills. Use AI to augment your capabilities, but do not let it replace your critical thinking. 10th, consider the broader impact your automated workflows have on your community and organization. Following these 10 guidelines distinguishes professional integration from high-risk experimentation. We have now built the complete architecture: a secure perimeter against injection, a hardened shield for data, an epistemic filter for truth, and an ethical framework for oversight. This architecture converts a volatile experimental tool into a reliable professional system. By neutralizing threats and verifying data, we gain the ability to deploy AI in high-stakes environments where errors carry real-world consequences. The AI serves as a mirror for the operator's standards. It reflects the rigor, intent, and accountability that we bring to the prompt. This synthesis of technical skill and operational rigor defines the standard for professional AI integration. By mastering these safeguards, we move from passive users to responsible digital citizens capable of navigating a complex AI landscape.